Afternoon, everybody. So it's the 10-year anniversary of Lambda this year, which is super exciting. That I think that 10 years ago, something that was so innovative launched, and 2 years before Lambda went live, Werner Vogels, our CTO, made this bold statement that in the future you will only be responsible for writing business logic, and AWS will just take care of everything else. And it was with that vision that he really set the roadmap for serverless. And so today, I'm going to spend the next 45 minutes talking about how to build a production-ready serverless platform. In order to launch business-critical applications, I'll be talking about a bit of theory for about 15 minutes, and I'm going to hand off to Kieran and Katie from Fidelity, who are going to take you through one of their workloads and how they do this in practice. And then I'm going to finish up with a little bit about how to get started on this journey. So when Werner made that bold statement that you're only going to write code, he then put some tenets around how we go and do that and built a mental model. And that mental model was about the shared responsibility model and undifferentiated heavy lifting. And so the idea was that you're responsible for some of the application, we're responsible for other parts, and we should be responsible for the parts that are not a differentiator for your business. In the EC2 model, that was pretty straightforward. We looked after buildings and hardware, and you guys looked after your operating system, your application, and their dependencies. And as we move towards a serverless model, we take on more and more responsibility. So actually, we're not just responsible for physical hardware and buildings, but we're actually responsible for where your compute is, having enough spare compute, so if there's an error, we're weighing away to another availability zone. And we're also providing primitives like storage, like S3 or EFS, databases like Dynamo or Aurora, and then the kind of glue that sticks those applications together are our messaging and orchestration services. So we also provide all those in a fully managed way. So the promise is that you can think about building APIs to interact with your applications and the business logic that drives your business forward. And that's all super cool. And when customers get it right, it's amazing. So Dave Anderson, who's probably, if not in this room, in the building somewhere, he used to be CTO at Liberty Mutual, said that by delivering serverless and by moving to a serverless first strategy, they were able to release features faster, they were able to respond to their customer demands quicker. And super importantly, you've been hearing a lot about generative AI today. When some new transformative technology comes along, you're able to quickly go and experiment with that technology without having to have a big capital expenditure and build infrastructure to do that. And one of the big value propositions for doing that is the ability to create two pizza teams. So two pizza teams are a concept that we think about at AWS a lot. And that is breaking into teams of somewhere between 6 to 12 people who are directly aligned to a bit of customer value. And I think the reason we do that is interesting. There's a guy called Dave Limp, who's our SVP of devices. He said, if you want to fail at something, make it somebody's part-time job. And so what we want to do is we want to make that team directly responsible, have a single-threaded owner, and very, very, very close to the value that they're delivering. And that's really, really, really good values, and it's something we still hold true here at AWS. But it's not quite that simple. So these two pizza teams are very, very closely coupled with the DevOps revolution and this concept of you build it, you run it. So I started my career as a software engineer about the start of the new century. And when I started doing that, I was responsible for writing code. I wrote code in my IDE, I bundled it up, and I threw it over the wall to the infrastructure team, and I forgot about it, and I moved on with my life, and then started writing new features, and life was good. And then DevOps kind of started happening, and we suddenly started being responsible for automated deployments, and suddenly I, as an engineer, was responsible for building code and shipping it. I'm shipping it, so maybe I should look after it too. So now I'm on call, and I've got to look after those applications that I'm writing and I'm shipping. We moved to the cloud model, and suddenly we're no longer have security that's at the perimeter where there's a big network firewall at the edges. Actually, security is now the responsibility of me as a developer to configure my IAM permissions, my own VPCs in my applications. We moved to serverless, and suddenly serverless becomes on demand, and you're priced per unit of compute you use. And now it's my responsibility as a developer to write efficient code that isn't going to ring up a great big bill. It's no longer the responsibility of an infrastructure team who's just ordered racks, and then we can use whatever we can get our hands on. And then now in here in 2024, we're all talking about the biggest challenges we have to face. We also now have to think about how green is our code? Are we using the right silicon? Are we using the right patterns to be ecologically responsible as well as technologically responsible? So this view of the serverless promise of we only have to think about the application code, the business logic we have to write is kind of at odds with this you build it, you run it, unless we get the right kind of practices and principles right. So we talk a lot at Amazon about mechanisms and building mechanisms so that we can do these things at scale without them being a huge heavy lift and a big manual job. I think a really, really important mechanism as we move to this new world is the well-architected framework. So well-architected framework, if you haven't used it, is a bunch of questions you can ask yourself about your applications. It has a serverless lens, and funnily enough, it aligns to a lot of these things that I've been talking about. So are we operationally excellent? Have we got secure applications? Are they reliable? Are we being sustainable? Are we managing our cost effectively? There's still quite a lot to do, so we also have to think about our team structure. So whilst two pizza teams are still important and still a really, really core part of what we do need other functions that sit alongside them to make them efficient and make them effective. So the team topologies model is something that I talk about a lot with customers. And so alongside those stream-aligned two pizza teams, we typically bring on a platform team. And so that platform team is building enabling technologies that help those teams deliver. So they might be building observability, security best practices. They might be building patterns and reusable templates that other teams can then go and use to build their applications. Alongside our platform team, we might have enabling teams. And so these are teams of senior engineers, of distinguished engineers who are going in, who've got deep knowledge about our business and technology, who can go in and accelerate those stream-aligned teams. So you might have a brand new stream-aligned team who is getting up to speed with the cloud, needs some help. Your facilitating team can drop into that team, help them build their pipelines, help them build best practices, and then when they're done, maybe codify that and bring it to the platform team. Or they might be going and jumping into one of your most mature teams who's really, really innovating at the edge and working what they're doing, documenting it, and again, bring it back to the platform team so it can be shared across the organization. And then finally, we've got those really, really nutty, gnarly problems in our business that everybody needs and we're repeating over and over again. So we've got these complicated subsystems. So maybe identity and access management is really challenging and we don't want all of our teams reinventing that. We might build a team that's just dealing with those complicated subsystems. And in that case, maybe it isn't really closely aligned with customer value, but the business has decided it's a strategic thing that we need to build and helps us succeed. So we've got all that cognitive load of the you run it, you build it world. We've also got the world of serverless. So the great thing about serverless is we've got the widest range of managed services that you can use, that you can combine together to build these amazing applications. The challenge is, look at all the services we've got that you can choose from to build your applications. So even if in the world of compute, you might be using Lambda, Fargate, AppRunner, you might be running Kubernetes. If you're in the world of databases, should I be NoSQL? Should I be relational? Should I be using Aurora Serverless? Should I be using Aurora Standard? How am I doing messages? Should I be thinking about streams or queues or buses? So there's an awful lot we have to think about when we're building these applications. And of course, even for serverless first customers, they're not all in on serverless. So almost all of our customers will have things that are built in serverless. They might have a Kubernetes footprint, and they could choose to run their applications there. They've got legacy applications running on EC2, and almost everybody I speak to has some form of on-premises data center, and probably will do until the time I retire. So we have to also ask ourselves, where am I going to run this application before I even ask how am I going to architect this application, before I can even ask myself, how do I operate this application? So this is where we really see the most advanced platform teams go beyond just providing IAC templates and observability tooling, but actually start to build patterns that are combined with great developer tooling and guidance. So in this example here, we might have a backstage implementation that has some really, really good patterns in it. And we might have a pattern here for Spring Boot 3 applications, brand new greenfield Spring applications that can use Java 17. That means they can take advantage of things like Lambda Snap Start for super fast startup time. We might have a pattern that we're going to do integrations through EventBridge. And we've got API Gateway that's already configured for developers with our authorizers and authentication policies. We might also have a pattern for our legacy Spring applications, and we've got thousands of them, and they might not be ready to be aggressively modernized to Lambda yet. and they can't be upgraded to Java 17, can't use Snapshot. Actually, maybe we want to think about containerizing those in more of a kind of lift, tinker, shift model. We might have a whole bunch of data processing workloads, and we've got some really, really big batch data processing jobs that we're running with Apache Spark. We can plan those. We know they're going to happen every evening, and so we can do all kinds of planning, provisioning around how we're going to get that compute. We want to run something that's very, very close to the metal and benefit from things like Carpenter, so we can get spot instances and a really, really great unit cost for compute. And equally, we might have real-time data processing costs that are also using Spark code, but actually we want the answer tomorrow, right now, within the hour. And there we want to use Lambda so we can scale out to hundreds of terabytes of RAM and tens of thousands of CPUs in just a few minutes to get the answer right now at a cost trade-off. And so we also want to understand where are we making the trade-offs, how are we making the decisions, and have a framework for developers to do that. And then, of course, alongside that, the kind of table stakes is providing a kind of consistent observability plane, so maybe having an open telemetry configuration so that we can manage all of our logs and distributed traces across these distributed applications, build pipelines, deployment pipelines. We want to provide good security tooling, so we might want to have a firewall, detective controls, protective controls that are pre-configured for teams. And of course, we want to have a handle on our costs, and we want to be able to do that across the organization, not just within a team. So we want to have some consistent way of doing that. So all of those things together reduces the cognitive load of your engineering teams, and as well as the stuff that AWS is doing, continues to help developers be really responsible for driving that business value. There's a little bit of theory there. I'm going to hand off to Kieran and Katie from Fidelity Investments, and they're going to spend the next 15 or so minutes talking about how they're putting this in practice.
Thank you.
Kieran. Katie.
So thanks so much, Matt, for giving us the opportunity to be here today. We want to talk about our experience building a production-ready serverless platform. So I'm Katie.
And I'm Kieran. And again, we're here today to talk to you about an application re-architecture that our team was tasked with. But first, can I put a hands up if they actually know what Fidelity Investments does?
There's a few anyway, which is good, but not to bore anyone else with too much detail, we are in the financial services sector. We have over 50 million customers managing trillions in assets. We have 74,000 employees across the globe who are dedicated to strengthening and emboldening our customers' financial well-being.
So, as you can see, it's actually quite important for us as an organization to maintain readily active and high-performant applications to enable our associates embolden our customers' financial well-being.
So when we were tasked with this application, what we wanted to do was redesign and enhance an existing on-premise application. This application was about access controls to AWS, so role-based access control, or otherwise known as RBAC. So we wanted to give users the opportunity to access and modify their resources within the cloud. So we wanted to identify what would be crucial for this application. The first thing was we knew RBAC was pivotal and mission critical. We would need to have this application at the same criticality level as the most critical and complex apps hosted within AWS. If one of those apps were to go down, then they couldn't get into their accounts, which is the gateway. They can't go in and fix that. That can lead to serious reputational or financial damage. Because of the mission criticality of this app needed to be constantly available. It wasn't really good enough if this app was going down due to outages or anything like that. Teams needed to be able to go in and fix any issues that would come up. Along with availability, performance was really important, so we needed to meet really stringent performance benchmarks. We wanted to ensure users could access this API at all times, so particularly during peak market hours. We needed to be able to let the app scale up as we needed. So we wanted to ensure then we would have some kind of event streaming or something to help with our performance. Finally, we wanted to ensure that it would be widely integrated. So we wanted to know, can it meld with other platforms and services, particularly EKS? So we wanted a suite of tools that we could use to inject things into other applications, especially for monitoring, deployment, or development. Okay, so now we know what we wanted to get out of this application. Next, we need to figure out how we want to build it. So in working in technologies these days, the bad and the good part is there's so many options to do the same thing. So what we wanted was to choose the right option, and we wanted to spend a lot of time exploring different platforms and services. As part of both myself and Kieran's job to enable our app team customers to have like a productive and simple experience in the cloud, we kind of wanted to eat our own dog food here a little bit and use services fully or at least partially within AWS.
And I was a major proponent of containers. Several years ago, Fidelity started utilizing containers in EKS in order to kind of store their applications, and it provided us with the added benefit of being able to encapsulate your entire application within a single container. And then what it also did as well was it allowed us to really configure that container so we could, dictate our runtimes, our dependencies and variables within. It also added a streamlined approach for like packaging the application quite neatly, which again, deployed across many nodes, allowed us to be highly available and also fault tolerant. And as Matt had already previously explained, our cloud sector within our organization is built quite like the team topology that he explained. We have our platform teams and our enablement teams, especially for containers, which allow us to provide loads of support to our developers and our development squads. So when they're going to deploy their application, they're there for them.
Yeah, I completely agree with what Kieran is saying. When we migrated a lot of our on-premise critical applications that were quite complex, going over to EKS and containers worked really, really well. So they worked really well with that level of configurability and the support from the platform teams. For this application, it's just as critical, but the functionality is actually quite lightweight and simplistic. So having all of that configurability and having the rigid structures of the platform team and having to set all this up would just kind of be a lot of wasted developer time. And as well, when working with EKS in a large organization like this, sometimes you can reach cluster limits if there's too many nodes. So that can kind of cause like a tug of war between app teams or even within our own applications on who would get the lion's share of resources. On the other side, serverless, which we hadn't really looked into, offered a lot of potential but was relatively new.
And again, that's hard to argue with, but operating in the serverless domain, it was a new kind of territory, a new kind of approach for development that provided a steep learning curve. Our container applications, they were well documented and they are highly replicatable, which kind of is a stark contrast to like starting off this serverless journey.
Yeah, no, I completely agree with that. But when we look at serverless, first of all, our developers were really excited to work with something new, so that's always definitely a plus. If we even looked at things though like networking management capabilities, if you're going to work with EKS, generally you're going to go with a third-party provider for your networking solutions. So we knew we wanted to create a custom authorizer which could basically give access through ORBAC. So if we were to do this through EKS, we would need a third party, and then we'd have to make an extra call, and there would be more latency within the app. But with a bit of investigation on serverless, we could use AWS Lambda and API Gateway basically to make those requests really simply.
Yeah, and I get that, but also comes the kind of topic of standardization within the code. And again, when we talk about team topology and enablement and platform squads, like they really do help bring and set out the frameworks for building out your standardization when they set those rigid structures for how you're meant to deploy your container services in the cloud.
Yeah, and that's great and everything, but the main thing here is we wouldn't have to manage our containers. Like Matt was saying earlier, with the you build it, you run it, there's so many things that developers have to do now. If we could get away from that and also not have to worry about outages or upgrades on those containers that could potentially bring our app down, especially when we want to be a highly available application.
Okay, and I do stand here convinced. And for this application, we did decide to go with a serverless solution. And this is because we found for this application it provided the right solutions in terms of being highly available, performant, and efficient for our use case. So we did go forward with a serverless solution for this. And also just when we talk about the serverless revolution, you know, this is a beast that has been like, and it's a community that has been like growing steadily over the last months and years. And it's really a beast that just keeps on continuing to grow and evolve. It provides, it helps us obviously, and this is obviously due in fact to the investment that AWS has been making in their services. Like we see that their services are highly integratable between each other in their environment, and again, that's just due to the investment. However, our mission critical APIs have never been more agile because of this. Like the serverless approach, once it's fully scaled up, provides a really quick mechanism for delivering features out to your customers as quickly as possible. Like historically with our container solutions, it could take 40 minutes to scale up an application and go from your local IDE out into production. And that's just running through an SDLC with your Docker image going up, running through an SDLC. With serverless, we're doing this a lot quicker, and we're deploying pretty much like the whole application from its components, from networking components to the actual infrastructure to then the bare bones logic itself.
As well, we see with observability insights, the ability to implement all the observability tools that AWS offers has given us a more fine-grained ability to control and understand our application. So with distributed tracing and logging and metrics, we are able to not only get like alerted if there's health check failures, but also for the per person that's stuck on call, they're able to go in and look through the logs really simply by just looking for a UUID or identifier. For event streamlining, so I know everyone hopefully knows what a watcher script is. We're hoping that this is going to be the death of that. Now what we can do with this is use an observability pattern, and it'll do the waiting for us. And it's going to watch for a change in state or resource, and then it will execute our functions automatically. So we don't need to worry about that, hopefully making our app more dynamic and more scalable.
One massive benefit that our application lifecycle gets when we move to serverless is the ability of shifting responsibility left. So the team doesn't have to worry about like their dependencies or runtimes. Like all that gets pushed back onto AWS, and it allows your developers and your squads to focus their really valuable time on delivering features and not wrestling with those end of lifecycle dependencies. And then, which comes forth with this, is probably one of the most beneficial thing we see is that the power of the integrations with serverless. And especially this comes with state management tools, like with the likes of like Terraform, with your own state backend, you can really rapidly like deploy out applications, cloud native, and test out, make rudimentary tests, which we're finding really beneficial in the application lifecycle.
Cool, so on to behind the scenes. So this is the architecture of the application that we built. So we knew it was mission critical. Again, we knew we wanted to provide like just-in-time or back access for our app team users to access and control their accounts. So the first thing we knew we needed was the custom authorizer. So again, that's just getting our users UUID or identifier and validating that against what they should have in their ORBAC roles. So it was actually relatively simple to do this using Lambda. Given the amount of power tools, and you can just insert an AWS layer, there's so many of them on open source, we were able to do that relatively quickly. We then had that connected to an API gateway and another Lambda for that, and our DynamoDB.
with the priority of the application, we knew it had to be highly available and performant. The first steps, of course, is making sure that the application is accessible. So for this, we set up a Route 53 with an LLB to open up the application so it could receive traffic.
So with that core logic kind of out of the way, we wanted to add in CloudWatch and more importantly, health checks. So now we don't need to worry about error handling. So the health checks are going to check, let's say we get a load of 500 errors. It's going to automatically take away the region that is down, and Route 53 will take that down and spin the app up in our other region.
So our active-active multi-region approach ensures that the application is both obviously accessible, limits user impact, and prevents production downtime, and also production incidents causing downtime, but also allows us to troubleshoot in case we do have those production issues. Also on this architecture, we were kind of worried about the introduction of Lambda and what that would mean for the application in terms of latency. You know, we've all heard about the dreaded cold starts. However, with the implementation of
the warm starts, isn't it?
With the introduction of warm starts and provision concurrency, we were able to tailor our lambdas to make sure that we were able to configure our latency that it didn't go under our service level agreements with our customer, which was highly beneficial. And again, this is through provision concurrency by setting up invocation environments, making sure that as soon as the customer is making a call, our application was pretty much being executed straight away.
And finally, we implemented global replication on DynamoDB. So this ensured that our users' requests were both executed and maintained, even in the event of an outage. With DynamoDB, unlike a lot of other databases we've interacted with, the ability to set up global replication is really simple. It's just when you're setting up your DynamoDB, you're clicking a few buttons compared to having to deploy infrastructure in both regions. So that was definitely a big benefit for us.
So we live and work in a fast-paced environment. Like, we all want to deliver for our applications and get them to market as quickly as possible. But we do know that this prevents a few issues. I imagine some of us, if not all of us, can say that they've seen software duplicated across their organization. That a team built a product to solve a problem that a team had already built somewhere else that was mostly the same. And we have to ask ourselves, like, how do we prevent this? We believe that the answer resides in reusable application templates. Using a developer portal or a tool such as Backstage, allows us to have a unified space where we can pull down fully templated applications. These applications would include your kind of standard application structure. So for a serverless API, we'd have your API gateway, your custom authorizer, a Hello World Lambda, along with the SDLC. So as a team or as a developer, you're pretty much good to go straight out of the blocks. And with this, we get a lot of good benefits. And similar to the patterns that Matt was talking about earlier, we do get the standardization of patterns. And what the standardization of patterns brings is it brings that applications following the same structure across our whole organization are following the same standards. So the same coding practices, logging, error handling, security practices, they're all baked in. And we do have to ask ourselves, how do we get to that level? Well, it actually all comes down to the community and having an inner source mindset. So with a good community of inner sourcing that kind of revolves around the pillars of transparency, collaboration definitely, and the shared ownership of the code. So we all own these templates. What you start to see is that you get your contributing model back to your templates. The templates become stronger, more impactful, and then what we find is it bubbles up, and now all of our applications hosted in the cloud are more resilient, more impactful, and easier to extend.
So finally, we want to talk about some of the benefits we experienced while transitioning from on-prem to serverless architecture. So the first one was high performance and availability. We moved away from regular outages and downtimes due to upgrades and various other reasons to achieving the 5 nines of availability. This meant as long as AWS was operational, our app was basically operational. In situations where we would encounter maybe multiple 500 error codes, our app would just automatically switch over to our active region, meaning we wouldn't have any outages or downtime. And not to jinx ourselves, but since we deployed this just over a year ago, we haven't had to go in and triage a single issue. So any failures had automatically migrated over, so we haven't actually had to go in there and do anything about that.
So another benefit and a personal favorite we have are personal deployments. So again, with the use of our state management tools, such as Terraform, what we're able to do is we're able to deploy out our coded changes to a lower environment, make our rudimentary checks before it's time for PR or run through STLC or all of those good Agile ceremonies, and again, make those rudimentary checks and make sure that everything is working as expected.
With seamless integrations, so we weren't too surprised that the AWS services all worked really well with each other. But even still, the use of the power tools in the AWS Lambda saved us so much time in writing code and also in managing dependencies. As well with that API gateway, it was so simple to just implement your API in any of our platforms, particularly our EKS platform. And along with that on API Gateway, we were able to automatically generate Swagger pages, so we were able to use that for testing or give to our users as well. One other thing was the way we were able to manage our dependencies. So if one of our Lambdas failed, the whole application wouldn't go down basically. This is in stark contrast to one of our EKS solutions where recently we had an outage which was caused by a dependency failure. Then that caused the health check to fail and subsequently then a crash loop back off, bringing the whole application down. It's no surprise that we're going to actually migrate that application over to serverless later this year as well.
Adaptive scaling. We know that scaling from an EKS point of view probably provides more control from a cost perspective. However, again, as we mentioned with Lambda and API Gateway, we're not too concerned about user impact, and especially with our provision concurrency and tailored Lambda warm starts, we're pretty much executing business logic from user invocation.
And finally, as Kieran was talking about earlier with the reusable application templates, our ability to see success across the whole organization rather than siloed into our own projects is kind of hugely to this inner sourcing mindset. We're all able to reap the rewards of this. And with that and the standardization that comes with that, we also have more standardization across all of our platforms. So then our users are getting a more standardized or streamlined experience. So thank you very much for listening to us today about our journey on building a production-ready serverless platform. If you have any questions after, feel free to come up to us and we'll give it back to Matt. Thank you.
Thanks, Kieran, Katie. It's always so cool to hear from customers who are building amazing things and just seeing people move from a world where you're patching and maintaining stuff and spending all that effort doing undifferentiated heavy lifting to a world where you have no planned or even unplanned or even planned outages in your most business critical systems is awesome. So I thought I'd just spend the last sort of 10 minutes talking about how do you start this journey? What does it look like, particularly if you are an enterprise? And customers often ask me, why serverless? And I think that's absolutely the wrong question. We should be thinking, when do we modernize? Because a cloud migration should always be followed by modernization. We see a lot of customers who start by lifting and shifting onto the cloud, and Gregor Hope, our principal evangelist, says, if you migrate onto the cloud, all you get is a nicer data center. And a nicer data center is nice, and it's a really, really important first step, but if you really want to get the benefit of the innovation and stuff we're doing at AWS, you have to think about modernizing some of those applications in order to use some form of higher order services. That means you've got a big estate of stuff you need to modernize. How do you think about doing that? I would suggest starting with some data. So I'm a big fan of the cloud intelligence dashboards. Cloud intelligence dashboards you can stand up. You can pull in a whole load of AWS data. You can bring that into a data lake, and you can start to process that and automatically start to generate some actionable insights. A lot of these insights align to that well-architected framework I was talking about. So you can start to see where are the applications where we've got gaps in security, in operations, where are we spending a whole lot of money we don't think we need to spend, or where have we got potential sustainability issues. We should be taking all that data, and I typically think about looking at both quantitative data and qualitative data. So first off, is this application even suitable for serverless? Maybe it's a Windows GUI application that frankly is never going to run on Lambda. That's totally cool. Don't think about it, take it off the table. We want to start to think about what are our SLAs, what's our uptime guarantees we need to make, what are our latency requirements, and we should do that in a way that's hard and tangible and based on business requirements. I was having a conversation with a customer a couple of weeks ago where they were really, really challenging the idea of moving to not just serverless, but to microservices at all, because communication over network is always going to be slower than communication in memory on the monolithic mainframe that they are currently running. When we spoke to the business, they were saying, we're not worried about the speed of this thing. It's actually going too fast. What we're really concerned about is when we ask you to change something, it takes 2 years. We're willing to trade off some of that SLA in order to get business agility. So understanding what your real SLA is really, really important. You should think about what's driving your application. So is that coming from all the AWS native stuff? Obviously stuff like SQS, SNS, API Gateway integrate to the serverless world, but also so there's a whole bunch of open source stuff. So if you're being driven by Kafka or ActiveMQ, or you're working with SaaS providers like Salesforce or SAP, those things also integrate really, really natively, so that's worth doing. However, if you're building some integration between on-prem IBM MQ platform and some other on-prem system, maybe serverless isn't the right choice to be connecting those things together. You should be thinking about your traffic pattern. Is this something that's super, super predictable? And we want to do a batch workload at the same time every day. I've got all day to provision those resources. I don't really care if it slips a little bit. Or maybe then I want to be thinking about running closer to the metal and benefiting from things like Spot. However, if it's unknown, it's variable, it's spiky, it's low, then maybe there's a traffic patterns you should think about. But we also want to combine that with our qualitative data. So when we're thinking about security, we want to understand what does our team look like? Have we got the resources, the capability to take on greater ownership of security? Do we want to look after operating systems in that team and container security? Maybe you've already got that capability stood up and that's fine. Or is this a leaner, streamlined team where we want to shift that responsibility left to AWS and spend more of our time delivering business value? We should be thinking about the business priority. Is this the application that's going to make us our next $1 billion and improve our customer experience by a huge amount? Or is this an application that's been delivering value for the business for the last 10 years and it hasn't seen a feature in the last 3 financial quarters? In that case, maybe you just want to containerize, stick in, do a light touch modernization, and that's absolutely fine for the business. You want to think about what's your timeline for delivery. Have you got time to do an aggressive modernization, or have you got a screaming feature that needs to be delivered tomorrow? And that might mean that you're doing a light touch modernization today and you're leaving your further modernization to another point in time when you've got some more capability. You want to think about your team expertise. So have you got a huge bench of people who are experts in serverless and you're willing to crack these projects? Or have you built expertise in other technologies that you want to leverage? I would say that just because you don't have expertise in serverless doesn't mean that you shouldn't have it, and people who are working in technology should be constantly growing and building their skills, and this clouds thing seems to be around to stay, so I expect engineers would want to jump on board. And like Katie and Kieran said, actually when given the opportunity, people are usually pretty keen to get on board and learn. And then finally, we've got sustainability. So I think that sustainability is super important. And you might look at your application and stay and do some data mining with your cloud intelligence dashboards and find applications that aren't necessarily a business priority, don't have business drivers for change, but actually they're burning a whole load of CO2 unnecessarily. And it could be quite an easy light touch modernization to make a really, really big sustainability impact. I think we should always be looking at in part of our model. Well architected is super important, and I think it is often left to something that's done maybe once or twice a year on a few key applications. I really like Dave Anderson's Scorps model that he built over at Liberty, which is building in a light touch well architected into your weekly sprints. So you're not doing a full well architected review, but you're just looking at your application and saying, is there something that we can do to improve security? Is there something we can do to improve reliability? And then using inner sourcing to then go and socialize that with your team so you grow best practice. I think that you've got to be mindful of operating models. So I think it's dead easy to say we're going to adopt DevOps, we're going to a you build it, you run it model, even we're adopting a squads and tribes model. But actually it's much more nuanced than this. I'll talk really quickly about 3 you build it, run it models. The first one is splitting out your application team and your platform team. In this model, your application team builds and runs your applications, and your platform team builds and runs your platform. You have centralized governance delivered by the platform team. You have another you build it, you run it model, where actually the application teams are responsible for building and running their applications and some of the platform. And you've got a platform team that's codifying some of those things the application teams are doing and making them reusable components. In this model with decentralized governance, it's not that we've got no governance, but you have to have a whole bunch more capability and skills in those platform teams to be able to operate this without tripping over your own feet. But if you can achieve it, this is where we see customers get a really, really high degree of agility. So finally, if you're really early in your cloud journey and you've got a whole lot of upskilling to do, you can have a model where you've got a you build it, you run it model. It's still a DevOps model. However, you've got an application team who's responsible for applications. You've got a platform team that's responsible for platforms. But we've also got this cloud enablement team that's almost like an internal consultancy that's dropping into your new teams, is helping people configure their pipelines and their dependencies, and really, really upskilling those teams. And over time, your application teams take on more responsibility, and your platform team builds a whole bunch of new capabilities. So these are all out of the well-architected framework. In the operational excellence pillar, there's these 2x2 representations. There's a whole bunch of other ones that are not you build it, you run it models, which are also equally valid, but worth doing. I've also talked about a whole bunch of bottom-up stuff, so things that engineers and platforms are doing from a technology level. I also think it's super important for our technology leadership and our enterprise architects to set a strategy and to be really, really mindful about the leadership. So I think that we should be having a high bar and setting an ambitious goal. So this one might be, we want every team to have a documented business outcome for what they're supposed to deliver. We might say we want to be secure by design, and we've got a process to review people's designs. We might adopt DORA metrics, which are industry standard metrics around kind of DevOps maturity. So we might want to measure our throughput or our error rates. We might have some kind of architectural guidance, so we want to prefer to rent or reuse rather than build. Or we might want to have something like an AWS, where everything that we build has to have event schemas and documented APIs so other teams can adopt it without having additional engineering work. Or you might want to have all of our solutions should be simple microservices that we can draw on one whiteboard and an engineering team can fit in their head. You can combine that with something that's really, really measurable, like a big goal. Within 18 months, we want 80% of all of our developers to be able to execute a well-architected review with a serverless lens, something you can put a training and enablement program in and help upskill the whole organization. And having that kind of top-down vision for how you do it is just as critical as all the kind of bottom-up tools, processes, and skills that we're building. But of course, it's a massive journey. Amazon's on this journey as well, so we've been doing this cloud stuff for a while. So the last 20 years, we've been building and maintaining Amazon, and so we're moving from that world of kind of on-premises to inventing EC2, and guess what, we've still got a whole load of Amazon is running on EC2, through to that journey where more and more things are cloud native. So I think it's really interesting that Andy, our CEO, has an interesting quote that if he started today, he would build Amazon on serverless. So I started off with Werner's vision at the end. At the beginning, Andy's at the end. Thank you so much for spending the last 45 minutes with me. Haven't got time for questions, but I'd love it if you had gave us some feedback. If you wanted to chat to me, Kieran, or Katie at all about any of the stuff we talked about, we'll be kind of hanging around the back for the next 15 minutes. After that, meet me in the pub, probably at the Fox.